Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and we are discussing on the different types of surfaces in sequence stratigraphy. And as part of that, part of this particular series of these different types of surfaces, now we are discussing about the surfaces which form during the base level rise. In the last lecture, we have discussed about one such surface, the maximum regressive surface, and in this class we are going to discuss about another very important surface which is associated with the base level rise, and that surface is called as maximum flooding surface, abbreviated as MFS, maximum flooding surface. So, in this lecture we are going to discuss about the different aspects of maximum flooding surface. So, as I have told you, the maximum flooding surface is another surface which forms during the phase of base level rise. So, if I refer back to that basic fundamental base level curve, in this curve, as we already know, the transgressive phase starts from here to here. Before that, this is the normal regressive phase, or rather this entire phase is the regressive phase. So, this surface in the last class we have seen, this is the maximum regressive surface. Now, after this maximum regressive surface, we get a phase of transgression when the base level rise is more with respect to the rate of sedimentation, and the end of the transgression and start of the next regression, that is this point, start of the next regression. So, this surface, that turnover, end of transgression and start of the next regression, that particular surface is identified as the maximum flooding surface. So, basically this marks the end of the transgression, peak of the transgression, and with this surface the next regression starts in the depositional cycle. So, this particular surface separates the retrograding strata below, because the underlying package is a transgressive package. So, it is a retrogradational fining upward package. So, on this package what we are getting is start of the next high stand normal regression, and during this normal regression what we know, there will be a coarsening upward package, a progradational package. So, this is the surface which marks the end of the transgression, the transgressive systems tract, and start of the regression in the form of high stand systems tract. So, a fining up succession changing over into a coarsening up succession, a retrogradational straddle stacking pattern changing into a progradational straddle stacking pattern. So, that particular surface is identified as the maximum flooding surface. So, this surface is always a downlap surface. Why? Because if I think of, say, this is the last surface formed at the end of the transgression. Now, on this surface the next progradational package is forming, the high stand normal regressive package is forming, and when it is a normal regressive package, the clinoforms will prograde like this. So, when the clinoforms are prograding, so this surface is acting as a downlap surface. So, always the maximum flooding surface is a downlap surface for the overlying prograding strata. The changeover from the retrogradational to the overlying progradational stacking pattern, it takes place during the base level rise at the shoreline, and we already know that during this particular phase the rate of rise of the base level overpaces the rate of sedimentation. So, this TST, or rather this effect of transgression in terms of sediment package accumulation, can be identified in two distinct areas where the TST package finally grows up, finally develops two distinct wedges. One we can observe in the continental shelf area, which includes self to shallow marine part including the coastal part, and the second one is the deep water environment or deep water part of the marine basin. In between these two areas, these two wedges, there remains an area which is a sediment bypass zone or a sediment erosion zone, where we do not get any deposition during the transgressive phase, which is commonly observed along the self edge area. And since there is an erosion or bypass is going on, so we cannot trace the maximum flooding surface over there. Since we are not getting the TST package to form over there, we cannot trace the maximum flooding surface in that particular area, that particular zone. So, effectively the maximum flooding surface occurs in distinct parts, distinct portions of the basin. It is not traceable across the entire basin. So, each of these transgressive wedges is topped by a conformable maximum flooding surface, which envelops the fluvial landscape when we are looking into the marginal part of the basin, or it downlaps the shallow to deep marine sea floor in a basinward direction. So, we can try to understand this with a very simple diagram. Say this is the continental part, then this is the shallow part, then we are reaching to the shelf, and then this is the slope to deep basinal part. During the low stand part, low stand deposition, we get a formation of fluvial aggradation and formation of a prograding package over here in the marginal part of the basin, forming a delta. In the shallower part, we get shore deposits followed by the self deposits, which are also prograding to some extent. The maximum deposition occurs over here, forming a self edge delta, and from there we can get some mass flow deposits occurring over here in the deeper part of the basin. So, this is happening during the low stand systems tract or low stand normal regression at different parts of the basin. So, after this the base level is rising up, and due to that rising base level condition, now what we get is a transgression. So, that transgression initially starts over here. This is one package, it tries to cover up this part, and the second package that covers up over here, which can again be divided into three different zones. One is the self area, second one in the marginal part, which you can call as the coastal onlap, and the third one over this fluvial part, which we can call as the fluvial onlap, and this one is the marine onlap. So, we can identify the transgressive package in three distinct zones. One is a marine onlap occurring along the slope area, second one in the marginal part of the basin where you are getting a coastal onlap, and third one is a fluvial onlap. And apart from this, we can get some amount of deposition, a very thin deposition in the self area, which may form a self onlap in the selfal area. But then remains this area, this particular zone, which is basically the self slope break. So, along this particular area, we do not get any deposition during the transgressive phase, and since we do not get any deposition during the transgressive phase, we cannot trace the maximum flooding surface over here. So, we can get a maximum flooding surface over here, we can get a maximum flooding surface over here, and we can get a maximum flooding surface in these zones. So, for each phase of the onlap in different packages, we get separate maximum flooding surfaces, which may be contemporaneous in terms of their deposition, but they are not continuous in terms of their distribution pattern. So, the maximum flooding surface, these are generally conformable, excepting for the outer shelf and the upper slope region, where this particular surface does not form at all. Commonly, this particular surface show relatively low diachronity along the deep direction. However, the diachronity may increase along the strike because of variability in terms of sediment supply and the accommodation creation along the strike direction. This is one of the easiest stratigraphic marker, easiest stratigraphic surface to identify within a succession, because this marks a changeover from fining upward to coarsening upward. So, very commonly, very popularly, it is used for the subdivision of stratigraphic successions, and it is correlatable across the basin, particularly when we are getting straightway the onlapping packages, for example, the fluvial onlap part, the marine onlap part, coastal onlap part, and in between the self area where we are getting a thin deposit forming, which may not be in terms of its thickness, in terms of its distribution pattern, may not be exactly correlatable with the onlapping packages, but that can also be correlatable, as we can identify that package forming in the self area as a condensed section. So, that condensed section, which is a characteristic of transgressive package in the self area, that also indicates maximum landward position of the shoreline. So, we can correlate this condensed section with the maximum flooding surface. So, maximum flooding surface is forming on top of the onlapping packages, and that can be correlated with the condensed sections forming in other part of the basin, for example, in the self area. So, now the question arises over here is, what is a condensed section? A condensed section, these are relatively easy to identify, easy to correlate on any type of strata, any type of succession, as they commonly consist of fine grained hemipelagic to pelagic sediments, which are accumulating or accumulated during the time when there is a minimal terrigenous sediment supply into the depositional system, say for example, within the self-hull area or in the deep water environment. So, think of a self environment where the water level is very high because of the transgression is going on, but due to that transgression, the supply of the coarser fragments, terrigenous fragments from the landward side is restricted because of that extreme water level. So, now what is happening in the self part? Those sediments which are available in suspension within the water body, they starts depositing in the form of hemipelagic and pelagic deposits. So, definitely their rate of deposition is very slow. So, within this phase of transgression, what we get over here, a very thin layer, very thin deposit in comparison to onlapping packages forming in the coastal area, forming in the fluvial part. But that condensed section demarcates that there is a very high water level, and we can correlate it with the corresponding maximum flooding surface. So, very often these condensed sections, these are associated with stages of maximum flooding, and they may be very much distinct in terms of certain characteristic properties. For example, they may contain certain minerals like glauconite, which is a very distinct green color mineral that may present within mud or sand, and that indicates a marine condition, marine flooded condition. Many times we can get siderites or other carbonate or biochemical precipitates to accumulate within these condensed sections, which are characteristic for the identification of condensed sections within sedimentary successions. So, definitely this maximum flooding surface, they have a very high preservation potential, because they are overlying a fining upward succession, water level is rising rapidly, and finally, when it is ending up with this maximum flooding surface, the water level is very high, and under this high water level condition, the overall energy of the system is significantly low. So, in such condition, the preservation potential of the maximum flooding surface is significantly high, as it is overlain by the aggrading and prograding high stand normal regressive deposits. And these aggrading and prograding high stand normal regressive deposits are commonly devoid of any erosional features. So, these maximum flooding surfaces can be identified in all depositional environments within a sedimentary basin, seaward to landward from the shoreline, on the basis of this changing stratal stacking pattern. Below the maximum flooding surface, it is a transgressive package, so it is retrogradational. Overlying package is a normal regressive package, high stand normal regressive, so it is aggradational with progradational. So, a distinct changeover in stratal stacking pattern also helps us to distinguish or identify the maximum flooding surface. In a marine succession, the maximum flooding surface is placed at the top of the fining upward deposits which are forming in the deeper part of the basin. That particular trend is generally valid in both deep water setting, where the maximum flooding surface marks the top of the waning down gravity flow deposits, which forms the base of the high stand pelagics. So, we can understand this with again a very simple diagram. So, now we are looking into the deeper part. So, this is the part of the shelf and we are coming to the shelf edge break to the slope and the deep basinal part. So, during the low stand phase, particularly at the end of the force regression and the low stand is starting. So, at that time commonly we get deposition of sediments, accumulation of sediments over here in the form of a prograding delta system. Commonly we call it as the shelf edge delta. Now, as the base level starts rising and the transgression is started, what we get is start of the onlap. So, the onlap package starts like this. Very often these are also called as the healing phase deposits, as they are covering up this gap which has formed during this force regressive part. So, when this onlap has started, these are nothing but the deposition of successive gravity flow deposits, and these gravity flow deposits are actually retreating back. So, we are getting one phase of gravity flow deposits, the next one is like this one, like this, the next one is like this, and it is going back like this. So, we are getting successive gravity flow deposits, but those gravity flow deposits are retreating back gradually. And when it is ending up over here, when the base level is at quite high level, at that time it is ending up over here, which is the end of the transgression, and then we are getting a HST condition when the base level is further higher, but by the time the overall energy condition over here in this part, already we are getting a condensed section in this shelf area. A condensed section in this shelf area, which is equivalent to the maximum flooding surface in the shelf area. So, that condensed section, which is nothing but the deposition of pelagic and hemipelagic sediments, so that actually hinders the successive supply of next phase of supply of these gravity flows in the deep basinal part. So, during the HST phase we get continuous this hemipelagic and pelagic mud deposition over here. So, in this part the maximum flooding surface can be very easily distinguished, can be very easily demarcated by this ending up of these onlapping gravity flow deposits overlain by these hemipelagic or pelagic deposits, which indicates the HST phase. So, this is the characteristic we often observe in the deep basinal part. So, this is the marine onlap part, the marine transgressive package is forming in the deeper part of the basin, and that leads to the maximum flooding surface in the deeper part of the basin. From the shoreline, if we move on to the seaward side, if we look into the shelf area now, the transgressive deposits may be reduced to an condensed section, or in some cases if the supply of finer sediments are not that high, we can entirely miss the entire transgressive package in the shelf area, outer shelf area along the shelf edge. So, in such condition the maximum flooding surface is superimposed on the earlier surface, which may be the maximum regressive surface, and it becomes very difficult to separate out, because there the overlying package is missing. So, in such cases the maximum regressive surface and the maximum flooding surface, they merge together. During the shoreline transgression, as the sediment supply is decreasing in the self-hull area, so that often leads to formation of or development of local firm ground condition or maybe local hard ground condition, depending on what type of sediments are available, how much gaps are there in between the sedimentation, and accordingly we can get firm ground or hard ground ichno assemblages within these condensed sections or within these self-hull sediments. So, this actually depends on what is the degree of seafloor sedimentation in these areas, how much time gap is there in between the sediment deposition, and that controls also the kind of organisms which are available, their diversity, their density. So, all these factors together will control what will be the final ichno assemblage, but we can expect formation of firm ground or hard ground ichno assemblages. But also along with the maximum flooding surface, very often we get characteristic soft ground ichno assemblages, particularly where the sedimentation rates are significantly high enough to maintain an unconsolidated sea floor and producing a favorable energy condition for the organisms to thrive over there. So, ichnologically, the maximum flooding surface is often identified as a very distinct stratigraphic contact. So, this indicates a period of relatively low sedimentation rate or a phase of non-deposition where lack of clastic input allowed for concentration of certain minerals like glauconite, and that results in intense seafloor burrowing and increased cohesiveness of the substrate. In ichnological term, often we identify this kind of surfaces as an omission surface. So, maximum flooding surface often represents or identified as an omission surface, and an omission surface is very important when we are trying to understand the series of events, the depositional events which are occurring in a depositional basin. So, maximum flooding surface can represent as an omission surface in terms of ichno assemblages and ichno fabric within a sedimentary succession. Now, if we look into the relatively shallower part, there we can get more variation in terms of the ichno facies, because in the landward shift of the facies in the shallower part, where we are getting contrasting facies architecture as the transgression is going on, relatively low energy deeper facies is coming over the shallower facies. So, accordingly we can get also the change in the soft ground ichno facies across the firm ground. Say for example, the Cruziana ichno facies below overlain by Zoophycus ichno facies, which is a much deeper ichno facies, which is a much lower energy ichno facies coming over the Cruziana ichno facies. So, such kind of ichno facies changeover across the surface helps us to identify the maximum flooding surface. Also, the increased level of bioturbation in the frame of ichno fabric can also take place at the maximum flooding surface, particularly when it is associated with the soft ground without much changes in the ichno facies, which also correlates with the relatively lower sediment supply, relatively lower energy condition during the time of maximum shoreline transgression. So, sudden increase in bioturbation, the level of bioturbation, the intensity of bioturbation leading to higher bioturbation index within the sedimentary succession can also help us or give us clue that possibly there is a maximum flooding surface. Now, if I look into the coastal settings, the maximum flooding surface is commonly placed at the top of the youngest estuarine facies. As we have discussed earlier, as the transgression goes on, transgression continues in the coastal area over the fluvial system or over the earlier deltaic system, now we get estuary. So, the maximum flooding surface is commonly placed at the top of the estuarine depositional system. So, this is the youngest estuarine facies that will demarcate the maximum flooding surface, and that also marks a turnaround point to subsequent delta plain sedimentation. So, again we can just try to understand this with a very simple diagram. So, in the marginal marine part where a fluvial system is coming into a coastal area, so there the sea level was somewhere here, and at that time the river system was supplying the sediments and it was accumulating over here in the form of a delta. Now, the transgression has started. So, due to that transgression, the delta system is changed into an estuary, and the river system, which was earlier a braided system, is now changing into a meandering river system. So, we can get a contact over here between the estuary and the meandering river system. Now, at the end of this transgression, what will happen? Further the base level will rise, and with this rise the sediments supply, rate of supply of the sediment is increasing. So, effectively what we will get, the meandering river system will continue, but it will show relatively more amalgamation of the channels, relatively less abundance of the overbanks, as well as the estuary facies will end up and will get a delta system to develop again. Now, that delta system will be showing more aggradation, more aggradational pattern over here, and that aggradational pattern will be represented by the amalgamation of the delta plain deposits over these estuarine facies. So, basically what will happen on these estuarine facies, we expect more fluvial system to come over here. If it is within the estuary system, we know that channels are affected by tidal currents. So, as now this aggradation of the fluvial system is going on as part of the delta plain, so the effect of this tidal influence will be gradually decreasing. So, that will indicate a sharp change in the facies pattern, in the facies architecture across this particular surface, and we can put the boundary over there as the maximum flooding surface. So, in the marginal marine system, straightaway we can get a changeover. If I see the facies contact, if this is the facies contact between the estuary followed by a meandering river system. So, this will immediately change now and will get a delta will start forming over this estuary, and the meandering river will change into a braided river system with time. So, during the HST phase, we get a sharp changeover from estuary to the delta in terms of facies changeover, in terms of stratal stacking pattern, nature of stratal stacking pattern, in terms of shift of the depositional conditions, in terms of shift in the facies architecture. So, the landward from the coastline, the criteria for the recognition of the maximum flooding surface in the fluvial portion of the basin is based on the presence of tidal influences within the fluvial sandstone or fluvial sediments. So, now the question arises over here that what are the tidal features that can give us this particular clue? What are the sedimentary or biogenic features, structures that can suggest us about the tidal influence, so that we can demarcate this? So, within the fluvial strata we can get sigmoidal bedding, which commonly forms under a tidal system when a tidal ripple, particularly the humpback ripple, that migrates forward. Similarly, we can get paired silt mud drapes on sand, commonly we identify them as the tidal bundles. We can get wavy and lenticular bedding, particularly within the overbank areas. We can get shrinkage cracks within the relatively distal part of the tidal flats. So, commonly we will get them in the overbank areas of the channels. Multiple reactivation surface within the bars, the channel fill sediments which are forming within these channel systems due to frequent fluctuation in the river energy condition due to tidal effects. So, multiple reactivation surfaces in different directions. Inclined heterolithic strata, another very important feature commonly identified within tide dominated river systems. Bidirectional crossbeds, sometimes resulting in herringbone cross stratification, very rarely, but bidirectionality in terms of the orientation of the forceps within the crossbeds, and some characteristic trace fossils, their occurrences. For example, pteridolites, for example, arenacolites, for example, scolithos, their abundance decreases drastically. So, when we get these features, combination of these features together, and we see that these features, their abundances are decreasing within the sedimentary succession within the facies architecture, that gives us a straightaway clue that the tidal influence is decreasing. So, we can put a boundary that the facies architecture is changing from an estuary to delta plain. Further upstream, the maximum flooding surface corresponds to the highest level of water table. As we are saying over here, the water level, the base level is rising up, and as the base level is rising up, the fluvial graded profile will also try to rise up, and that may lead to rise in the adjacent water table. So, a rising water table, a high level of water table with respect to the land surface, if associated with relatively lower sediment input, relatively higher organic material supply, and appropriate or supportive climatic conditions, that can lead to formation of peat, accumulation of peat, which results in formation of thick coal deposits. So, very often this particular phase, this maximum flooding surface, it can get associated with thick coal deposits, regionally extensive coal deposits. So, in rock successions, if we are getting regionally extensive coal seams, which can be laterally correlated within a fluvial system, we can understand that possibly this is the maximum flooding surface within the fluvial system. Definitely, in this kind of scenario, the fluvial system is associated with the marine base level change. Only in such cases, this kind of coal seams can be very easily identified. The position of the maximum flooding surface in entirely fluvial successions can be demarcated by an abrupt increase in the fluvial energy. When we are reaching into the maximum flooding surface, the energy condition is significantly low, water level is very high. So, the overbank deposits are more dominant with respect to the channel amalgamation. So, channel fills are relatively scattered, they are distributed within relatively thicker overbank deposits. Within the channels, the marine signatures in terms of tidal signatures are absent. So, in such cases, we commonly get a meandering system, meandering fluvial system. And as we are moving into the overlying HST part, the normal regressive part, the supply of sediment is increasing, the accommodation is gradually decreasing, which leads to increasing energy condition, and the river condition, river type changes from a meandering to a braided fluvial system. So, the end of the estuary lifetime triggers a rapid seaward shift of the river mouth, and that seaward shift of the river mouth leads to formation of a delta. So, on the estuary we get aggradation of the fluvial system, which actually is a part of the delta forming at the river mouth area, which is actually part of the shifting delta mouth area forming above the estuary system. So, if I just try to explain this, say if this is the maximum flooding surface and below this we are getting the estuary system, say for example this is the estuary system. So, when this maximum flooding surface is reaching, that is the end of the transgression, this is the meandering fluvial system. So, on this system now what will happen? There will be drastic change in the energy of the fluvial system. So, this meandering river will be changed by a braided river system in this part, and by the time over here we will get the meandering river system moving over here on the estuary system, and this meandering river system is producing a delta plain or maybe even a delta front system in front. So, over here in this part, the delta plain and delta front, they are part of a delta which is forming over here, which is produced just because of the coastline which was earlier here is moving in this direction. As the coastline is moving, the river mouth is also moving, the river mouth sediments are also gradually prograding, resulting in shifting mouthward system, shifting delta front system and the shifting delta plain system. So, since we are getting sufficient amount of accommodation, there will be aggradation of the delta plain, aggradation of the meandering river system, but there will be change in the energy condition as the supply of sediment is increasing, as the river equilibrium profile is changing. So, across this particular surface, this maximum regressive surface, we get a very drastic change in terms of the facies architecture, in terms of the depositional systems. So, this change in the fluvial systems or fluvial styles across the maximum flooding surface is commonly represented or identified in terms of changing grain size pattern, in terms of grain size threshold. So, within the high stand fluvial deposits which overlies the maximum flooding surface, it commonly records an abrupt decline in the tidal structures and a gradual increase in the degree of channel amalgamation. So, in this part, when we are looking into this braided river, we get multiple channels, they are getting amalgamated together, whereas in the meandering river part, maybe somewhere here, if we try to see what is the channel pattern, there the channels are isolated like this, and the intermittent areas, they are actually the overbank deposits, they are all separated by the overbank deposits. So, the overbanks are much more thicker, much more widespread in this area, whereas when it is reaching into the braided river part, the channel systems, they are all amalgamated together with very less amount of overbank deposits. So, this changeover is represented by number 1, the abrupt decline in the tidal structures that we have already discussed, and there we get a changeover from estuary to a delta plain, and the fluvial system, its changeover is represented in terms of gradual increase in the degree of channel amalgamation as the amount of available accommodation decreases towards the end of the base level rise. So, if I want to conclude over here now, so maximum flooding surface is another very important surface in sequence stratigraphy, and they indicate the end of the transgression and start of the regression during one cycle of base level change. So, they are very much characteristic, very much distinct in terms of their appearances, because they separate a retrogradational or fining up package below and a progradational coarsening up package above, which can be very easily identified. Based on the nature of transgression, we can get transgressive wedges or transgressive packages forming in different parts of the basin in different sectors, and accordingly we can get or trace the maximum flooding surface at the top of those onlapping packages, which can be correlated with the condensed sections commonly that get deposited in the self-hull area, which indicates a very high water level condition at the end of the transgression. So, maximum flooding surface is a very important surface in sequence stratigraphy, and this can be used as a sequence boundary, as we have seen in our earlier discussion, in our earlier lecture when we discussed about the different types of sequence. So, maximum flooding surface can act as a sequence boundary, as well as it can act as a systems tract boundary, as it separates the TST, the transgressive systems tract below, and the high stand systems tract above. So, we will discuss about the transgressive package, transgressive systems tract in more detail in later classes, and there again we will refer back to this concept of maximum flooding surface. these are some of the references that you can follow for further reading. So, thank you everybody.